Namaste, this is JVN Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss on the module n into 2 game by graphical method. That means the solution of n into 2 game by graphical method, and this session is a part of the course Operation Research under the program of BBA 6th semester and BBA LLB 6th semester of the university. The game theory is a very important subject of the course Operation Research, and as all we know that the Operation Research will be used for the best or the appropriate decision theory and decision making. So one of the model of the Operation Research is the game theory, and in the game theory various methods are there to solve the games, and in the today's session we are going to discuss about the solution of n into 2 game by graphical method. N into 2 game means that is just one player will have n strategies there. N means it is a general value, general number, so means may have 3, 4, 5 or more values, more numbers, strategies, while the other player, second player, will have only 2 strategies for this game. And the graphical method can be considered as a good method because it is relatively faster method. Comparatively it is a quick and faster method, and therefore this can be taken as a good method for finding out the solution of a game in game theory model. And one of the thing is that the graphical method is applicable whenever the one player will have only 2 strategies, and the other player may have more than 2 strategies also. So this is the condition for the applicability of the graphical method. And now we are discussing about this method. So when means suppose when we have a game of with n into 2 strategies, and then or 2 into n also, so the game can be reduced for the 2 into 2 game also if it is possible by the use of the dominance rule. And if it is not possible, then still the problem can be solved by the graphical method also. And in the today's session we are discussing about that, and with also one example. So now we take slides for the explanation of this n into 2 game by this example, with complete explanation how to apply the method and what is procedure for solving the game by the n into 2 method. So now we take slides. So here n into 2 game by the graphical method is given, that n into 2 game by graphical solution, and one example is given that and in this example we have to find the solution of game theory problem using the graphical method. So this is a kind of a game theory problem, and we have to solve it by the use of the graphical method. And here the 2 players are there, player A and player B, and player will is having the 6 strategies, A1, A2, A3, A4, A5 and A6, while the second player B have only the 2 strategies, B1 and B2. So here just how to solve this game. So just we will find first of all we will find the saddle point here, testing the saddle point, and player A and player B are this payoff matrix is given that for the player A and player B, and first of all we have to find here the row minimum and the column maximum values. For to find the saddle point, whether it will exist or not. So now we can see here the player A is having the strategies A1, A2, A3, A4 and A5 and A6, and the player B is having the two strategies B1 and B2. And first of all we have to find here the row minimum. The row minimum values are there -3 and 3, -1, +1, 2 and -5. So these are the row minimum values, and now we have to find out the column maximum values. The column maximum values are the these are the 4 and 6. So these are the maximum values in the first and the second column respectively, and we have found it. We have found the row minimum values and the column maximum values because we have to find the saddle point, and for the saddle point we have to find out the concept of the maximum values and the minimax values. So here first of all we have found here the row minimum values, and now what is the maximum value? The maximum value means the maximum value among the row minimum values. So the maximum values is here 3, and the minimax value means the minimum value from the columns, from the column maximum. So minimax value from the column maximum value is 4. So it means just we have found their minimax value and the maximum values, and we can see their row maximum value is 3, while the column minimax value is 4. Because these are not same, so it means the game has no saddle point. Because these are not same, so game has no saddle point. And now how to solve by the graphical method. So first we draw the two parallel lines 1 unit distance apart and mark a scale on each. Now we start to solve the problem by graphical method, and we have to understand what is procedure for solution. So first of all we can see the figure here. The two lines are parallel drawn here for B1 and B2. Now we can see for B1 and B2 these are the two parallel lines, and these are just drawn for the 1 unit distance apart. Means just suppose that the distance between the two parallel lines means B1 and B2 is 1 unit. So first we draw the two parallel lines 1 unit distance apart and mark scale on each, and we have just marked on the both lines. The two parallel lines represents strategies for the player B. So the both lines will represent the strategies for the player B. And now next, if player A selects strategy A1, and player B can win 1 or -3 units depending on B's selection of strategies. So as we can see the table there, so it means for the strategy A1 just corresponding to here 1 and -3. So 1 and -3 are the values corresponding to B1 and B2, and so we have to take 1 and -3 on these two lines. On these two lines we can see 1 and minus of 1 and minus of 3 on the two lines. So on B1 we have to take 1, and on B2 we have to take -3, and we have to draw a line, and then that is corresponding to A1. So we can see there in this way. Here just it is given that 1 point on the B1 line and -3 is on the line B2 is taken along the A1 strategy, that is clearly seen on the this graph A1 on the point 1 and -3 along the strategy 1. So just we have drawn these, and it means we can draw the line of this one, and the value 1 is plotted along the vertical axis under strategy B1, and the value -3 is plotted along the vertical axis under the strategy B2. So in this way just we can draw the first line for the A1 strategy, and here player B can win 1 or -3 units. We can see this point from the on the just payoff table. In the similar way we can draw the other lines. A straight line joining the 2 points is then drawn, and similarly we can plot the strategies A2, A3, A4, A5, A6 also. In the same way we have to draw the other lines for A2, A3, A4, A5 and A6 strategies, and the problem is graphed in the following figure. And now in this way we can just draw the these lines. We can see there along means for the strategy A1, A2, A3, A4 and A5 and A6. So these lines have been drawn. Next just now we have to find the value, optimum value. So in this graph we can see there just how can we find we can find it by the two methods. Here we can see the lowest point V in the shaded region indicates the value of game from the above figure. So the lowest point V in the shaded region indicates, so again we will see that that is the point, the lowest point in the shaded portion is given there, and just the lowest point is taken here, and this lowest point the lowest point V in the shaded region indicates the value of the game, and from the above figure the value of the game is 3.4 units. And now we can observe our graph that the value of this game will be 3.4 units by scaling. Just we have taken initially scale, and thus we can observe it is 3.4 units. And now we can find out it by one more method, like the point of optimal solution occurs at the intersection of two lines. So the point of optimal solution will occur at the intersection of two lines, and the two lines are given by like the first E2 and E4 are the strategies, the lines. So that is 3P1 plus 5P2, and E4 is 4P1 plus 4P1 plus P2. So these are the two lines, and the point of optimal solution can be just determined by the intersection of these two lines. So just we are comparing the above two equations, and we compare these two equations. So we will find out this line 3, this equation 3P1 plus 5P2 is equal to 4P1 plus P2, and as all we know that P2 is equal to 1 minus P1 because these are the probabilities. So P2 is equal to 1 minus P1, and putting the value of P2 in this equation, and so this equation will become 3P1 plus 5 into 1 minus P1 is equal to 4P1 plus 1 minus P1, and when we solve this equation we will find out the value of P1 as 4 upon 5. So the value of P1 is 4 upon 5, and the value of P2 can be just determined as 1 minus P1. So P2 becomes 1 upon 5, and therefore the value of the game will be equal to V is equal to 3 upon 3 into P1 plus 5 into P2. So that is given by 3 into 4 upon 5, and plus 5 into P2. P2 means 1 upon 5, and that is equal to 17 upon 5. 17 upon 5 means that is 3.4 units, and this is the value of the game. So in this way we have just determined the value of the game by the graphical method for that n into 2 game in the game theory, and students are advised to practice for more questions of such type, and also prepare the objective as well as the subjective questions. Thank you.